Heads or tails? Classical reality tells us there are only two options, heads or tails, even if I haven't looked at it yet. But in quantum reality, the coin hasn't chosen a side yet. It exists in the superposition of both heads and tails, until the moment I lift my hand. Quantum mechanics were first introduced in 1925 by physicists like Heisenberg, Born, and Schrödinger. Their equations show that quantum particles can exist in multiple states at once. However, the idea of a quantum superposition was most famously illustrated in 1935 by Erwin Schrödinger's thought experiment, Schrödinger's cat. In the hypothetical setup, a cat is sealed in a box with a radioactive atom, a detector, and a vial of poison. If the atom decays, the detector triggers the release of the poison, therefore killing the cat. According to quantum mechanics, before it is observed, a single radioatom can genuinely exist in a superposition of both decayed and not decayed. Because the detector is linked to the atom state, called quantum entanglement, it becomes both triggered and not triggered, and therefore the cat becomes both dead and alive. Counterintuitive, isn't it? Classically, we expect the cat to be either dead or alive, whether we look at it or not. Schrödinger's point was to show how bizarre it becomes when we extend the well-established superposition behavior of microscopic particles to a large familiar object, like a cat. Another experiment, called the double slit experiment, was originally performed in 1801 by Thomas Young to prove that light behaved as a wave and not a particle. It was performed by shining a single light beam through two slits with a wall behind it. When the light passed through the slits, it created an interference pattern on the wall behind it, proving that light behaved as a wave. The experiment was adapted centuries later to observe wave-function duality by gradually shooting just one electron at a time through the slits and observing the same interference pattern on the wall, showing that light behaved as a wave even when sent one at a time. However, when a detector was used to track which slit each electron went through, they seemed to change their behavior and the interference pattern disappeared. The electrons were no longer behaving as waves, they were behaving as particles while being measured. Feeling a bit confused? Well, you're not alone. Even Richard Feynman, who helped develop quantum electrodynamics, famously stated, "I can safely say nobody understands quantum mechanics." Even Einstein referred to quantum mechanics as God playing dice. Before measurement or observation, the universe does not hold definite values but probabilities waiting to become results. It's equally as fascinating and important to keep in mind that nothing is ever as it seems, and science relies on curious individuals like you and I to question reality, to look at what others consider obvious, and dare to ask, is it really?